Welcome students. In this video, we will be discussing about a tree traversal method called as in-order traversal. Already we have created a binary search tree. Now we want a traversal method to check whether that tree has been properly created or not. There are a lot of traversing technique available here. One is in-order traversal, pre-order traversal, post-order traversal, and level order traversal. And now we are not going to see every traversal now. First we will finish it out with in-order traversal. We will implement it, check whether the tree has been completely created properly. If it is so, then we will start with the other traversing technique, and we will one after the other we will finish it up. So initially taking an in-order traversal. In-order traversal. What is the technique of in-order traversal? The technique of in-order traversal is to visit left node and then reach root node and then right node. I'll explain you more about this left, root, right. What is the order? Order left, root, right. Yes, I'll just speak more about this. Okay, fine. Now you start your process from root. Okay, you start your process from root. Okay, you start your process from root. So first visitor node is going to be root node. Now every time the preference is given to the left node when it is coming to in-order traversal. So from whichever node I am now presently, I will first of all reach my left node. So from 89, I will try to reach my left node. Again coming here 12, I will again try to reach my left node. So wherever I am moving, I will first of all I will search for left node. Suppose if left node is not available, it means if the left node is actually null. If the left node is actually null, then what I will do? Then I will look for the second priority, which is given to root node. Which is root node means now the present node is itself root. It's not the root of the entire. It's not the root of the entire tree I am speaking about, because we are taking a pointer root, and the pointer root only you are moving to the second node. So now where the pointer root is now? So the last visited node, which is 12, it is now root pointer is available here in 12. So that root of data have to be now printed. So my first preference is given to a left node. So from whichever node I am now presently, I will be trying to move to my left node. Suppose in situation if left node is not available, if in the left node I am having null, I will stop and immediately print the data which is available in the root, present root. So left and then root. Okay. So the first data we will print out of this tree is actually 12. Now we have made a left and we have made a root. So after going very deep to the left side and after finding null, we printed the root of data, and now it's time to go for the right. So first importance given to left node. Then if left node is not available, then print whatever is in the present root node. Then you can now take a right side path. Now from 12, let me take the right side path. So right side path means the next visited node. The next node that I will visit will be 56. Okay. Now the root pointer is now available in 56. Now wherever I am, what I will do first of all, I will look for left. First of all, I will look for left. So left, is it available? Left is available. Yes, left is available. So I will move to 34. Again from 34, I will try to move to left side, but I find null. When I find null on the left side, I need to print the present root wherever we are standing. So 34 is the next data that will be printed. Now after printing, so left is completed, root is completed for 34. Now what is the remaining thing? Remaining thing is right. So what I will do, I will just try to go for right, but right is also null. When the right is also null, what I will do is I will now start backtracking, which means I will go to the previous node. So now 4 is printed and the left and right of 4 is completely checked. Now what I will be doing is now I will take this 4 out, so this node, and again I will go for this third node that I visited, third node. Now coming to 56, I think 56 all the left side element is printed. Left side element 34 is printed. After the left side process is finished for 56, now what you should have done? You should have come to this root and you would have printed the root element. So first preference is given to left. Next one is root, next one is right. So for 56 first preference you gave it to 34. That's a left. And left is completely printed. Process over. Now you have reached again to the root. Now this root data have to be printed, so which is 56 have to be printed. So next we will be printing 56. Now after finishing left and after finishing the root, now it is time for you to go to right. So you will never, from here you will be now reaching the node which is having data 80, the node having data 80. But whenever you go to any node, what you will search for? You will first of all search for left, but left is not available. When left is not available, you will print the current data, which is 80. So I will print 80 after 56, and after printing the data, then we will try to go to right side. But here right side is also null. When both left, root, right is completed for a particular node, you just backtrack again. So go back to again 56. Okay, go back to again 56. Coming to 56, now check for 56. 56 left is also completely finished. 56 of right also completely done. Left is completed, then you printed 56, then the right side is also completed. Now the job of 56 is completely over. Now you backtrack from 56 to the previous visited node. So from 56, I think from 12 only you reached 56. Now again go back to 12. Coming back to 12, left side is completed and the right side entire subtree is completed. 56, 34, 80 completed. Now the left is completed, root 12 is printed, and then the right side everything 34, 56, 80 is completely done. Now after left, root, right is completed for this node, you go back to the previous node. Yes, I am going back to 1. Left side is completely finished for 89, but still root is not completed. So now it is time to print as the root of data, which is 89. So after printing now the present root of data 89, so left subtree completed. Now root is printed, and now it is time to get into the right side. So when you enter right side, so right side means you will now enter to this node by having data to 100. So whichever node you are available, first preference will be given to left. So go to left, which is 93. And then from 93 you try to go to left where null is available. So stop here, and now what you have to do, whenever you found null on the left side, you can now print the present data. If there is no way of moving to left side, print the present data. So now the present data after 89 we will be printing is 93. After printing root of data, then we have to check for right. Right is also null. When left, root, right is completed, now it's time for us to move back to the previous node. So previous node means I will go back to node 100. For 100, left side is completed. Now you have to come here to root. So the root of data 100 will be printed after 93. So 100 will be printed. And after finishing left and after completing root, now it is time to move to right. Now it's time to move to right, and coming to right you have a node with number 3. Okay, now coming here. So whichever node you will look for left. Left is null. So when left is null, you will print the present data, which is 120. And then you will try to move to right side where again you are facing a null. So I will stop here. Now I will just again go back. So for 3, according to the node present node 3, all the elements on the left side is completed, right side completed, root is also completed. Now go back from here to the previous one. Left completed, root completed, right completed. Go to previous one. Coming to the main root node also, left completed, root completed, all the entire left, right is completed. So when all the elements are printed, now look at this element actually, look at the element. This is what the in-order traversal of a binary search tree. And also one more thing, if you observe, all the elements are in sorted order. All the elements are in sorted order. So coming to a binary search tree, if you want all the elements of a binary search tree to be printed to you, if you want to print it all in a sorted order, then you can go with this in-order traversal. You can go with in-order traversal. Okay, so suppose if already you have a binary search tree and you want to do sorting process, then it is very efficiently can be done with the help of in-order traversal. Just printing, we are not storing, we are not changing anything, we are just simply printing. Okay, fine. So this is what in-order traversal is all about. So first preference is given to left. You keep on moving to the left. If you find a null, now come and print the present root of data and then now start moving to the right side. So these three things have to be recursively taken place. These three things have to be recursively taking place. If suppose root is equal to null, you will stop. Root becomes null, you will stop, because your root pointer only you are moving to left side and right side, and root is becoming null. You can have that as a that has a condition for the recursive code. So we are going to do it in a recursive approach. So in order traversal, we are going to do in a recursive approach, right? So this is what in-order traversal is all about. First preference is given to left node, then the second one is given to the present root. Okay, it's not the root of the tree, it is the root pointer wherever it is available in that particular situation. Wherever the root pointer is available, that particular node is called as root. So that root of data will be printed, and then we will try to go for the right side. So left, root, right. That is why I'm saying that for in-order traversal, it is left, root, and then right. Now we will go for the implementation of this in-order traversal. Thank you, students.